Let's talk about industrial safety, in particular emergency stop relays. They're used a lot in industry to shut down machinery and processes very quickly and very reliably. You can get single channel ones or dual channel ones. This one's a dual channel, and what that basically means is 2 contacts from each emergency stop button is wired to it. In this example, I'm just going to use 2 links because I don't have an emergency stop button to hand. So when you first power these relays up, they're going to be in fault straight away, and you can tell this by looking at the channel 1 and channel 2 LEDs, which are both unlit. So to get the relay healthy, we can either link it out for an automatic restart, or we can put in a button for a manual restart. I'll just use a couple of wires that are touched together instead of a button. So once you've got both channels of the emergency stops in circuit and you've got your reset button, you'll then be able to reset the relay. Since the relay is energized when healthy, I've wired up an LED to the normally closed contacts to show when it's in fault. You can see this go off once the relay is reset. Both emergency stop channels are now lit up and the normally open safety contacts are now closed. So one of the main features of a dual channel emergency stop relay is the ability to detect welded contacts on the emergency stop circuit. So by breaking one channel of the stop circuit and leaving the other healthy, you can see the relay goes into trip. What I've just done simulates hitting the emergency stop button, but channel 2's welded closed. The relay is clever enough to know that even if you try and reset the emergency stop button, there's still an issue between channel 1 and channel 2, so it's not going to reset. To get the relay to reset again, channel 2 has to be broken at the same time as channel 1, and only when both channels are continuous again will the relay reset. This specific emergency stop relay comes with 3 normally open safety contacts, 1 normally closed contact, and 1 transistor output. The normally open contacts are usually wired to relays, contactors, or the load directly. My personal preference for the normally closed is for a lamp for indication, and then the transistor output are usually wired to a PLC. I'll then use this to generate an alarm on a HMI or a SCADA system. There's a ton more stuff that I could mention, like positive guided contacts, but I don't want this video to be 4 hours long. If you've made it this far and you've learnt something, feel free to give a like and follow. Thanks for watching, I'll see you on the next one.